is sort of fundamental to the rest of this unit. Okay, so this is called expressing equations of lines using vectors. Okay, so we're going to say here, the vector equation of a line is going to be vector R is going to be RO plus TM. Where
is that a zero?
Yeah, R naught, R0 or R naught, okay? So we're going to say where M is equal to AB, R0 is equal to X naught, Y naught, and R is equal to XY. Oh, stay with me here. In component form, then we're going to say the parametric equation of a line is X is equal to X naught plus T TA, and Y is equal to Y naught plus TB. Okay, so there's two ways we can express the vector. We can express the equation. Number one is with just a general thing. So you have a point, plus you're going to add a multiple of the scalar. That's what that says on the left-hand side. Or a multiple of the direction vector is what I meant to say. So on the left-hand side, R naught is just a point. This is going to be your line equals point plus your slope. Okay, that's what that basically means, okay? Tm is going to be like this. So m is your slope, t is what you're multiplying your slope by. All right? And then on the right-hand side, this is in component form. There are the way you put this down. These are two things that we're going to use every day, Hannah, okay, in this in the next week and a half, all right, and they're relatively important for the rest of this unit, okay. You know, to go back and forth to them is sort of important, so we're going to go through that right now.
Wait, what is T?
Sorry, T is just a constant. Because imagine, okay, I'm going to erase this in a sec, okay? But think of if you have a slope of -2, it means you're going down 2 and over 1, right? And so your slope is -2. But in order to get your line, you can do this twice, 3 times, negative once, negative twice, negative 3. You can multiply your slope however many times you want to. Okay, and that's all I'm saying here, right? Is your slope is going to be this, but you can multiply, in order to get a line, you can multiply it an infinite number of times.
Okay.
Okay? Okay, is everyone done with the left-hand board? Yes? Let's get some examples so we can get an application of this and sort of see what happens with this. Here we go. So example 2, what are we up to? Thank you. Example 3 says, determine the vector in parametric equations of a line passing through. A 1, 4 with direction vector M equals -3, 3. A, we're going to say sketch the line with 4 points. And B is we're going to say is Q -21, 23, or R -29, 34 on this line. Okay, I'm going to get out of the way here. I'll let you guys go back. I should be able to see now. Okay, all right. Okay, so do your best and scribble that down. We'll go through it. Technically, A would be the first part, I guess, and then B and C, but we'll do them in 3 different sections here. This is a fundamental question. Okay, so to understand this is really important. Okay, for going on through this unit, I can envision on your test it saying A is 1, 4, -2, M is equal to -3, 3, 1, like putting the third dimension into them. Okay, and saying is find the equation of a parametric and a vector equation, and then are these points on the line? Okay, that's definitely fair game would be. Okay. All right. Yeah.
What is the vector?
It could be. It definitely could. And I like the way you're thinking. So that was a good point. They said, could I not make this -1, 1? You totally could. Or 1, -1? You totally could do that. Okay, we're going to leave it at this because that's what it was given. But you're right on. You can divide them and multiply them by anything, and that'll work very good. Okay, okay, so let's go to solution. Does somebody want to be brave and try and give me the vector equation of the line? Let's write the vector equation of the line. Okay, Hannah, I'm going to pick on you. Okay, so if R is going to be something plus something, what's the first thing that the vector equation of the line has?
X and Y.
Yeah, so good. So what's my point? What's my point going to be then?
Would be 1 and 4.
Good. Okay. So you can be brave now and do the second part. Yeah, it's a slope. Okay. Now I'm going to just put a t in there because it can be any multiple of the slope. What we want to say. And then -3, 3. Okay. Now again, the idea is the slope can continue on forever, so you can multiply it by 10 or 1/3 like you did. That's good. All right. All right, James. It's time to be brave. Am I going to see your dad's height, by the way? And your mom?
I think so.
I'm going to hit pause. Do you want to hear an embarrassing story? Do you know they actually...
Oh, I think the internet wants to know.
No, they don't. I'm not going to. I won't say the embarrassing story. No, I'm not going to do it. We'll talk about it later. Okay. So we're going to do the parametric. I'll wait till I take a break, and then I'll tell the embarrassing story. Okay, so the parametric equation. James, and if you can't do, if we're not sure, that's okay, because this is the tricky part. So this is the component. What are the x components of that line, please?
Oh, like R?
Yeah.
1?
Yeah? Yeah. So I'm going to call it then, not just 1 - 3, but 1 - 3t. Okay, right? Because you're going to have the t comes with it. Okay, so everyone see how we did that?
Should we do the Y first?
Yes, you should. And Alistair is going to lead us through it. Alistair, what's y going to equal, please?
Y equals 4 plus.
Perfect. That's wonderful. Excellent. Tremendous. Is anyone unclear where those came from? Because this is where I need to make sure we're all rock solid. Except for Brandon, I'm going to skip his birthday today, so he's not going to get to answer today unless he wants to.
Okay, part B, we're gonna graph this. Now, what version is easier to graph? Well, it depends on how you feel, okay? You can do this and just pick t equals 0, 1, 2, 3, and 4, and you'll get coordinates for A and B, or for X and Y. You can do the same thing here to go, so I'll just graph this this is gonna be a rough sketch. So this is part A, is gonna be my sketch. Here's my first point, which is going to be 1, 4. All right.
What does the G mean?
T is just a number, like it's a multiple. Like, so T is just anything you're going to multiply by, is what we're saying. Emma, could you be brave, please? And give me another point on the line other than 1, 4. Negative 2, 7. How'd you get that? Yeah. So that should be up 3, and that should be negative 3. So this is negative 2, 7. Great. Hey, there was another point on the line, please.
Alright.
Okay. Oh, you went this way then? Yeah, you can go down. Okay. So all she did here was the x's, you're just following this, right? So your x is going to be minus 3 each time, or plus 3 you can do as well. And then your y is going to be plus 3. Okay. So the easiest one is just to go negative 3 this way again, right? And then up 3, which should take you to negative 5 and 10. All right. Okay, so everyone see that right? We're just going to go over 3 and up 3. Austin, can you be brave, please? Be brave to give me the next point.
Negative 8 and 13.
Negative 8 and 13. Because I'm cruel, and it's Bailey's turn. Bailey, if you want to continue on down this way in some direction, what would the next point be down this way?
Negative 2. No. Everything.
It's okay. Take a second.
4, 1.
4, 1. Very good. Okay, so what Bailey did, she's correct, by the way. This is 1, 4. Right? So what she did was, if you go down this direction, it's the same thing but opposite then, right? So this is going to be 4, 1. Okay. We'll continue up like this. Oh goodness, that's supposed to be a straight line. I'm sorry. Don't tell Mr. Lacey that I drew a line like that. Probably that was your teacher too, probably when I did that. So. Okay. All right, letter B. Says, we want to know if the point, what's the first point? Is the point negative 21, 20, 23, is that right? On the line. Now, I'm going to do this with algebra, okay? I'm not going to do this with logic or with, continuing my line out that far. That would work, okay, right? But I'm going to do algebra for this one. Let's go ahead.
Okay, so basically, when you drew that, you really didn't have to do like the parametric equation, but you did that just to show.
Yeah, the parametric equation I was asked to be given. The beginning part said, show me the parametric equation, like before part A, it said, write the vector in the parametric equation, so I wrote it out.
But, like, not that there will be a chance that this will happen, but if it just asks to sketch just that,
yeah,
you can just do that.
Yeah, definitely. Okay, so for how we're going to do this one, okay, so what you're going to do is you're going to sub negative 21, 23 into your parametric equation. solve for t. If the t matches, oops, there's my writing. If the t's match, it is on the line. So what I mean by that is, if when I do this at t equals 5 for both versions of the parametric equation, what that means is that you could multiply the slope by 5 and get that point, okay? But if one is equal to 5 and one's equal to 3.8, that means that there's not going to be, because they both be multiplied by the same thing, t should equal t. All right, so this is just a nice little algebra expression Brad's going to give me here. I'll give you the first line, Brad, and you're going to help me solve this. So the x was negative 21 equals, what was it, 1 minus 3t. And then I had 23 equals 4 plus 3t. Before I move on, I want to make sure that everyone is crystal clear on where that came from, because solving equations we're getting back into in this unit, okay, the algebra, stuff like that, we're coming back to again. Brad, you're good with where those came from?
Yeah.
Okay. Brad, can you show me your math skills and solve the left-hand equation for me, please, all the way down?
Your negative 22 is equal to 3t
Okay?
divided by negative 3.
Yes. Ooh. Okay, that's a yucky one. Okay, it's possible, but that looks gross to me. Okay? All right, Calvin, can you also do the right-hand side for me, please, if you'd be so kind, all the way down?
So the 19 divided by 3.
Oh, that was amazing, you did it that quickly. You were totally a calculus student. Oh, I love it. Okay, so what I'm saying is, if you were to multiply the x coordinates by 22 over 3, you also have to multiply the y coordinates, right? It just makes sense, okay? Because that would have to happen. So we say, therefore, not on the same line. Okay, because you can't have two different t values, because they should be the same t in both versions of the equation. Okay? So we're sort of feeling okay? Tana? Because you're going to be my next superstar here momentarily. Okay? Actually, I'm going to let everyone be the next superstar and try this out, and then Tanner's going to give me the solution in a sec, okay? So the second one said is the point negative 29, 34. Okay, so you guys solved that. I'll hit pause in the video. And then, James, can I tell them, not embarrassing, sorry, can I tell them a story about your dad, or the invite?